Hi, welcome back to the channel. Today we are going to be going over protocols in Swift, and we'll be taking this all the way from the most basic implementation all the way up to be able to start unit testing mockable protocols. If you're ready to learn more, then stay tuned. Let's learn together. So here we are in an Xcode project, and I've got a couple playgrounds set up ready to go to learn about protocols. The first thing that I wanted to go ahead and talk about was that while protocols may seem like a little bit more an advanced topic whenever you're first starting into Swift and iOS development, protocols are actually something that we use on a regular basis. So, for example, every time we make something conform to identifiable, identifiable is a protocol. So you're actually using protocols every time you say that something is identifiable. Or if something is encodable, decodable, or just codable, those are also protocols. And protocols not only work with structs, but they work with enums and classes as well. For example, another one that you've probably seen and even possibly used is adding a case iterable protocol to an enum type. And so what that would do is that would allow us to actually be able to iterate over every case in a for loop, for example, or be able to display each of these in a list in SwiftUI. But either way, the thing that I want you to just take away from this is that protocols aren't scary. We use them every day, and they are actually a really powerful tool in the Swift programming language. So let's go ahead and close out these built-in examples now that we've gone over a few of those, and let's go to a slightly more advanced example. It's not crazy, but let's check out this one. So in this one, we have an animal example. So our animal, we can give them a name, and they can speak. Now, protocols are generally named as some sort of verb, such as like codable, encodable, decodable, nameable, speakable. Those are the kinds of names that we generally use in Swift, and they're also capitalized by convention. Now, as we said before, we've got the speakable and the nameable protocols here, and we can create a custom struct that conforms to these protocols. So, for example, our duck struct conforms to speakable, so a duck can speak, as we can see here. So a protocol is a contract, and anything that implements this protocol has to adhere to that contract. So, for example, our speakable protocol says that there is a function called speak, and that function called speak will return a string. So anytime we use speakable in a protocol, we have to implement the speak function that returns a string. So here, as we can see in our duck example, we have one function called speak, and it returns a string. If we were to say comment this out, for example, then Swift would say, hey, your duck type doesn't conform to speakable. And it would make sure, the compiler would make sure that we are adhering to that protocol and adhering to that contract. Now, protocols don't only take functions, you can also give them variables. So as you can see in our nameable protocol, we have a name variable, and we can either get or set that variable. You could also do one or the other. So for example, if you only wanted to be able to get the protocol, then you could just take the set out just like that. And then you could only get the name, but you couldn't set the name. Now when dealing with protocols, you can also conform to more than one at a time. For example, in our dog struct here, you can see that we are conforming to nameable and our speakable protocol. And what that means is that we now have to have a name for a dog, and we have to implement the speak function for the dog. So we are able to conform to multiple protocols at the same time, which is cool. Now, like I said earlier, we can also use classes with protocols. And so one thing that you might remember from the Solid Fundamentals video that we did recently is that you can do dependency injection, and protocols are great for dependency injection. So here we can see that we have an animal that is speakable, and then we have our speak function here. And we are saying that this animal class takes any kind of animal that can speak. And so because of that, we come down here just below the class, and we are creating a dog that is an animal. And this animal, his name is Bingo. So we could say dog.speak, which is really cool because then we could pass in a dog that speaks, or we could create a duck, and we could say that this duck is an animal, and the animal is a speakable duck. And so then we could say that we have a duck that speaks. And again, this is another way of using protocols to dependency inject the type into a class, which is really cool. For now, let's go ahead and move on to our next example. So as you can see down here, we have a vehicle example. So we've got a drivable protocol, and our drivable protocol has two functions, one called start engine and the other function called drive, and it takes a distance that we want to drive, which is just a double. Now you may hear from other videos or places on the internet that you cannot set defaults when creating a protocol, and that's partly true. So you can't create defaults whenever you're creating the protocol itself. However, we could, in fact, create an extension on this protocol and set a default behavior in this extension, which is really cool. It's actually a built-in feature to Swift and is really nice and can come in really handy if you ever need to do that. So for our example here, we have a car struct that conforms to drivable, and as you can see, it's got our start engine and our driving function. And so if we comment our extension back out that has our default implementation, and then we comment out this start engine function, our car no longer conforms to drivable because it doesn't have the start engine function. However, if we go back and we add our default implementation in through our extension, as you can see, now car goes back to being able to conform to drivable because we've got a default implementation here, which is really cool. Now, let's go ahead and let's comment this out for now, and let's go back to making our car struct a little more reusable here. So now that we've got those commented back out, let's go back to our drivable example. And again, like I said earlier, we would talk about polymorphism. So polymorphism just allows you to write code that operates on a general type or interface without needing to know the specific concrete type of the object at compile time. This specific implementation of the operation is then determined at runtime based on the actual type of the object. So as we set up here in the animal example, that if we were to do this type of situation here where we could say a dog.speak and duck.speak, and they would do different things based on the type that was passed in, that's polymorphism. So we can come down here to our car example, and another way to look at this is our operate vehicle. So as you can see, in our class that is our car management system class, we're taking a drivable vehicle as the input to that class, and then inside our operate vehicle method, we are calling vehicle.startEngine, which is one of the methods from drivable, and we're also calling our drive function, and they are doing different things based on the type of drivable object that is passed in, which is really cool. And again, as you can see here in this class, we're doing our dependency injection of our drivable method. And now that we've kind of now that we've gotten a little bit more advanced, let's take it again another step farther, and we will go over mocks of our protocols. So we have a few benefits to mocking. One is that a unit test should ideally test one specific unit of code in isolation from its dependencies. This is one place where mocking protocols is amazing for what it can do, because it is completely separate and apart from everything else that we might do with a real class. Or even if we were to create a class and subclass it later, we would still be tied at some point to a concrete implementation, where being able to create a mock of a protocol is actually a lot easier to deal with. Another benefit of mocking versus testing a real class. So testing a real method could take some time, due to a long-running process such as like a network call, or it could be environment dependent. So I don't know about you, but some of the code bases that I've worked in, the test environments or the lower environments, they could have some kind of sketchy data in there, and it may not act like it would in production. So that's another benefit of being able to mock things locally. And another option where testing protocols really shines over a real implementation. So a lot of times a real implementation would try to write to a database or possibly write to a log file, and then that would have to be cleaned up later. Or you may have to create an in-memory database storage in your unit test. The nice thing about dealing with mocks is that there's no database setup that you would need to do, and there's no having to clean that up later, which is very nice. It makes your unit test really small and highly performant. So as you can see here, we are mocking our drivable protocol here, and then we've got a couple properties that we want to add just so that we can help test various other features of this drivable protocol. And we'll go over those here in just a second because we've also got some unit tests here that we'll look at. But as you can see, we can print that we've called the starting the engine. We can print that we have driven the distance of, X miles, whatever that gets passed in. And then we've got a couple of options here, and our start engine call count just checks how many times this function has been run. And same thing with our drive call count. It counts how many times that method has been run. And then we've got our last driven distance, so that we can be able to make sure that the distance that gets passed in is the distance that gets printed out here. And with that out of the way, let's go ahead and jump over to our test, and let's look at those. So as you can see here, we've got a couple of unit tests, and there's nothing fancy, but we are instantiating our mock drivable class here. And then we are creating a SUT, which stands for System Under Test. So for our example, we are testing that car management system that we were looking at earlier. And the vehicle that we're passing in is our mock vehicle, so that we can control all the things that are running inside of there. And then we've got a test distance so that we can see how far this car actually drives. So in our testing, you can see that we are making sure that our start engine count gets called once and only once, and same thing for our drive method. And then we are also making sure that our distances match up, so what is passed in is what actually gets printed out. And we're doing that for our operate vehicle method inside of our car management system. And then we're doing something very similar. We're doing the check vehicle for the long drive, but we're making sure that that drive count only gets called once, and our start engine count gets called not at all in this scenario. And then we're making sure that our distances actually match up. So that is one way that we can help use mocks to actually write some quick and easy unit tests. And just to prove that they work, let's run those again really quickly. Nice, build succeeded. Great, and test succeeded. Now, if you are interested in learning more about protocols in Swift, the swift.org site has a great set of docs on protocols, and don't worry, I'll leave that linked in the description below. And with that, feel free to like, share, and subscribe, and if you leave a comment, just be nice about it. That's all I ask. Thanks. Have a great day.